In this video, we want to find the intervals on which this function f of x is either increasing or decreasing. And we're going to use critical values to find this out. So to do that, we need to find the derivative to start off with. F prime of x will equal to, use the power rule first for the derivatives, so bring the 2/3 over to the front, and then subtract 1 from that exponent. 2/3 minus 1 is a negative 1/3, and then it's times, using the chain rule, derivative of 2x, or x squared minus 4 is 2x, and then we got the x squared minus 4 here. Let's rewrite this, multiply the 2 and the 2x over here, that'll give us a 4x, and I'm going to bring this x squared minus 4 to the negative 1/3 to the denominator, put it here with a 3, and that just changed the sign of the exponent. The x squared minus 4 to the positive 1/3. So now again, the critical numbers are numbers for which the derivative is 0 or undefined. We can see that the numerator is 0 when x is equal to 0. So one critical number is going to be 0. A critical number is also a number in the domain of the function. And of course, 0 is in the domain. And also where the derivative is undefined. So you can see here the derivative right here. X squared minus 4 factors into x minus 2 and x plus 2. So there's two numbers that'll make this denominator 0. 2, guess 2 squared is 4. 4 minus 4 is 0. That gives me a 0 down there. Negative 2 squared here is 4. Minus 4 gives me 0. So there's two numbers that make the denominator 0, which means the derivative is undefined at those two numbers, 2 and negative 2. So again, a critical number is a number in the domain of the function for which the derivative is 0 or undefined. So the derivative is 0 at 0, and it's in the domain. You can plug it in here and get a value. The derivative is undefined at 2 and negative 2, but those are in the domain of the function. You can put a 2 there and square it, a negative 2 there and square it. You'll get a number, no problem. So these are the numbers we're going to consider for this particular function. So here's what I'm going to have. The graph n is going to pass through the point negative 2, 0, 2, 0. And if I go back to the original function here and put a 0 where the x is here, 0 squared is 0. And then I get negative 4. That'll give me negative 4 to the 2/3 power. So the y-intercept of this graph is at 0 and negative 4 to the 2/3 power. That's approximately 2.5. So I can go up, then let's see, there's 1 up, 2 up, and about right there, 2.5. The graph is going to go this way. It's going to be continuous here. So it's going to go up to 2.5 somewhere in here, and then it's going to come down like this. So just from that information, I know where it's increasing and where it's decreasing, at least half of the problem. But normally the way you do it is on this number line here, we look at the sign of the derivative. So here's your derivative right here. When the derivative is positive, the graph is rising or increasing. When the derivative is negative, it's decreasing. So let's look at this interval right here from minus 2 to 0. Minus 2 to 0. We already see that it's increasing. But let's test it out with the derivative. So I'm going to pick a number between negative 2 and 0. I'm going to pick this one right here, negative 1. So let's plug negative 1 in here. So negative 1 for x on the numerator gives me a negative number, negative 4. But I'm just going to look at the sign. So it's negative. In the denominator, put a negative 1 here, and then you square it, and then you subtract 4 from that. That's going to be negative, and then to the 1/3 power, that's going to be negative. So get a negative over a negative. It's increasing. Let's double check this here. Between 0 and 2, you see it as decreasing. Let's see if this checks out. So now I'm going to pick a 1. Between 0 and 2, I pick 1. Put a 1 here in the numerator. That'll give me a positive. And put a 1 down here in the denominator. This will be 1 squared is 1 minus 4 is negative. to the 1/3 power is still going to be negative. So I get a positive over a negative. That's a negative. So in the interval from 0 to 2, it's decreasing. That's coming down. Between -2 and 0, the derivative is positive, so it's increasing. We have that. Now what happens to the left of -2? So to the left of -2, is it going to be increasing or decreasing? Well, let's pick a -3 over here. -3. So let's put -3 here where the x is. In the numerator, 4 times the -3, that's going to be a negative. So I've got a negative there. In the denominator, I have a +3. And then the parentheses, I have a x squared. I put a -3 there, square it, I get a 9 minus 4. That's going to be positive. And then to the 1/3 power, everything in the denominator then is positive. So I got a positive. So a negative over a positive tells me the derivative is negative. So this one is coming down or decreasing. So it's going something like this. And then it continues to rise out that way. Now what happens to the right of 2? Well, all we're going to do is just test it with one number. So we can pick any one we want. We could pick 3, we could 4, we could pick 1,000 way over here. It's going to be the same. All we want is the sign. Is it positive or negative? So let's pick a 3. 3 times 4 is 12. All I care about is a sign, so that's a positive number. And then a 3 in the denominator. I got here a +3 there, and then the parentheses, 3 squared, that's a 9 minus 4. It's a positive to the 1/3 power is still a positive. So the derivative gives me a positive number in the numerator, a positive in the denominator, comes out positive. So again, the derivative is positive. That means the curve is increasing or rising. So this is coming, something like that. Now, if it asks you for the graph, you have it. But all it wants is the intervals where it's increasing or decreasing. So let's find it out. Increasing and decreasing. So you can see negative infinity is over here to the far left. Plus infinity is to the right. So you can see on the far left over here, the curve is coming down or decreasing. So decreasing on the interval, negative infinity to 2. And you can see from -2 to 0, it's increasing. So increasing, -2 to 0. And then from 0 to 2, it drops or decreases. So it's decreasing on the interval from 0 to 2. And then on the interval from 2 on, it's increasing. So again, decreasing on negative infinity to 2, increasing on -2 to 0, decreasing on 0 to 2, increasing on 2 to infinity. Thanks for watching. Wish you next